Yes.
Yes.
We want to predict properties of molecules and reactions by looking at quantum features of electrons and ions. And today is kind of end of the first chapter where we look over basics. And in these basics, you guys did nice presentations of postulates, which I avoid to turn because they are not provable. They are just statements to do with it. And we spent time for doing the equation, time dependent, and evolution operator. Those things are made to predict future, right? So in some sense, this is a class of predicting future. By now we got about, well, I'm tired counting, but approximately 2 methods of predicting future, maybe 2.5. Like one with evolution operator, another with Schrödinger equation, which can be implemented in a form of finite differences, like wave function psi at t plus delta t equals psi at t, and in front you do 1 minus a combination of imaginary unit and Hamiltonian. Maybe you remember, maybe not. I wouldn't remember. I remember just by mumbling it from year to year. But there is those 2 first things, or 2 first ways to predict the future were probably I need to hear it. Otherwise, those who decide to listen wouldn't hear anything. Test. So there is a way. Well, okay. First 2 ways to predict future are good for philosophical acquaintance with the concepts and for numerical solutions by powerful computers, which were not available at the first at least 50 years of quantum theory. And there is a 3rd way of predicting future, which works for people who do not have computers, and for those who look forward to solve scary homeworks in the future, or to see that they're scary and abandon them. This method is the goal of today's meeting. And to those of you who are taking differential equations, right? This is just matching solution to initial conditions. Did you have this? Okay, so in some sense, it is applied differential equations. I will probably show a couple of slides to so that we feel comfortable and know where we should arrive, and then I block the screen and show something on the blackboard, because otherwise we will lose contact even with all good intentions. Nothing is more boring than watching slides. In previous years, there were pen writing on a screen, and then it was more funny when someone comes, derives, everyone applauds. Oh no, let's keep your glory in place. I will flip it at a time when presenting something. Okay, so well, this is something really. It's high school physics of free fall and adding together waves. Yeah, you can even do it before the end of the class. So here is a what?
I wasn't ready for it to be purple. Yeah, it matches also his hair.
I was impressed or surprised when we had a MATLAB meeting last Wednesday, and then Elsa lifts her hand, and I look at her, see the purple color. How to make curve of the purple color? It's for you.
So the first one is evolution operator, right? This exponential to the power of Hamiltonian. The second one is numerical wave propagation. If you know near future, we can predict closest. If you know past, present, we can know nearest future by delta t, right? And it is good to propagate in computer codes. And we are going to rederive this equation, which gives the same thing as the first two. We start from the past, so wave function at time 0, and we arrive to the future wave function at time t. And if you are taking differential equations, you see there are general solutions and with expansion coefficients, and we just need to match the coefficients to initial condition. So that's it. You can like stand up and leave because there will be nothing else. Okay, now I'm going to mute the screen. Maybe to turn this thing around and do some little exercises on the blackboard. Hello. Okay, so stop sharing. Okay, mute. Video mute on. Okay, but the recording is supposed. I recognize the hand of Sam. Probably he came this morning just to. Okay, I'm just wanted to set up. So do not write above this line. Do not write below this line. I do see camera here. And then if you watch, you'll see how it looks like. Okay, I've got credit for doing straight lines. Approximately.
Every line is a straight line.
In certain system of coordinates. Okay, so the main property of the eigenstates of the Schrödinger equation, of time-independent Schrödinger equation, is that they are orthogonal. What does it mean? Yes, perpendicular in multidimensional space, right? So scalar product of two wave functions will be either 1 or 0, right? Same as for two-dimensional vectors. So this means that if you have well, scalar product of wave function, let's say n, and wave function m is integral phi n star phi m without star dx should be 1 if they are the same, and should be 0 if they are different. How can we believe it? I wouldn't believe. I would just fall asleep immediately and tell like it's too abstract. Let's look on example. Suppose our functions are defined from -1 to 1, and suppose we have two functions. One is a step function that is equal 1 everywhere, and another is y of x equals 1 and another is y of x equals x. So if you do this little exercise and do integral, let's call it phi1 and phi2. So phi1, phi2 dx from -1 to 1. So it will be, first function is just 1. Even if you do complex conjugate, it doesn't change, times x dx from -1 to 1.
So why does phi1 get the little like star?
Because by definition, if we want a scalar product of two-way functions, we need to do conjugation. When they are really, doesn't matter, but if they start accumulating complex phase to match this property, suppose if you want to get one for function matching itself, if it accumulates phase phi n, if they both have the same index, then it will be quickly oscillating thing. And if they accumulate phase in the opposite direction, they cancel each other. So it's just made by humans for humans. What is integral of x dx? Thank you. And if we evaluate it from -1 to 1, so 1 squared is 1, -1 squared is 1, 1/2 minus 1/2, 0. So they're not normalized. If you do same function, it will be slightly different, but one can put it by prefactors. But you see how functions can be orthogonal, right? So this is the main property that is responsible for everything we do today. So it is a foundation. I'm going to erase it, right? So it was just a little example. And I think things in that corner are much more visible because the camera is at angle. So like here I'm this small and here I'm this big. Okay. So what are basis functions? Did you hear it in your differential equations or in? Okay, what are basis vectors in linear algebra? Okay, I have no doubts you know it. It's expressing questions in strange words always makes it a little surprising to express.
I don't know if I remember it right or not. I'm pretty sure a basis is like basis vectors. It's like a set of vectors that you can make like any vector in a set from
Perfect. So if you have if there is a two-dimensional space, you have vector, we can call it, some people call it I bold with vector, which is has projection 1 in x and 0 in y. And then one can have the vector j with projection 0 in x and 1 in y. And then any vector can be expressed as different letter r x projection times I plus y projection times j. Yes. So basis. Same with functions. So if you have basis functions which are a little bit more complicated and multidimensional, but we can tell like function 1, function 2, maybe more of those, and then projections on this direction, C1, C2, and this would allow to represent any like put big psi function as a linear combination of all basis functions. Linear combinations of all basis functions. Do you see any connections to your differential equations or not yet? Okay, it would be much better if I turned camera on you when we discuss, but then it will be hard to remount it here. I'm going to ask a question and just trying to find right words to formulate it. I need you guys to teach me, especially those who is taking differential equations. What is the difference between general and a surgeon? Joke. Between general and particular solutions of differential equation, or maybe partial, maybe particular, whatever, you know terminology better.
Yeah, the general is with like. I want to say that the general just lists like what lists C, and then the particular like find what C is and then like that value in.
Function with like some random constant and then particular defines the constant.
You agree?
I don't see the differential equation.
Agree,
Okay. It's healthier to agree.
Get it?
Yes, yes, perfect. It's really great. So, if we have, I'm just like a little silly robot repeating the same equation again and again. So, if we do have phi sub n of x, which are first, second, like progression of all of them, are they general or particular? Based on your words, which they look closer to general. Okay, perfect. This little expression, is it look more like general or particular?
Particular.
Yes. We do not know, but by linear combination, but by adding together several, well, if the coefficients are yet unknown, the solution, summation of solutions is a solution. And if we will take specific values for coefficient C, it will be particular. Would you agree? Okay. Now our goal is to find the values of these coefficients to construct a particular solution for a specific initial condition. Okay. To have things visible, I will erase and start over. Okay. So the
I appreciate it. I get much encouragement.
When we were solving the time dependent, well, we were not solving, but we were looking on ways how to solve time dependent numerical equation. We separated time dependence and spatial dependence, right? How did the dependence on time look like? What was it? First derivative equals to function itself, so you
I can pull up my PowerPoint.
just say by simple words.
Say it in words, what, can you repeat the question?
So the time dependence of the solution of time dependent Schrodinger equation, which function form does it have? Function form, is it like sine, cosine, logarithm?
Oh, it was exponential. E to the that.
E to the power,
whole thing.
e to the power of something, right? E to the power of what? Units.
H hat, H,
Time, and what is here?
H.
H if it is evolution operator. If it is, huh? If you are perfect, you know the subject. If you construct evolution operator, yes. But if let's do a little simpler. What are the units of the stuff that is here? Yes, energy. And if we already know the solution of, again, I'm like a silly robot repeating the same writing again and again. If you do know solution of the time-dependent Schrodinger equation, the energies of the eigenstates will fit into here. So we will have the energies of eigenstate in here. And if needed, we can rederive to do it more solid, but I would be happier if you just trust. So if you want a general solution of psi of xt, it will have a form of solution of time independent Schrodinger equation times e to the power of the energy. So eigen energy and eigenfunction both contribute to solution of time-dependent Schrodinger equation. And the energies which are real because of this Hermitian blah, blah, blah stuff that Sam was introducing, right? So real part here, imaginary here. So it's just accumulate as a spiral of imaginary exponential. So this function is stay where it is, but it just changes phase. But depending on energy, it accumulates phase quicker or slower. Okay. Or you do not like it.
Wait, say the question one
Okay,
more
I made it for the record. The class of 2022 doesn't like phase accumulation. Is it? Did I read your faces correctly? Because before. Okay, I cheer up myself by coffee. So
So what's the relationship with the psi xt and the, like, they're not equal, but they just are, they correspond to each other?
well, let's. It will be, yes, but if you change n to m, if you do summation of those, it will be still solution. I will get to it. I just want to make sure that you're a little bit more comfortable with the exponential. So I'm trying to be a little cautious so that no one catches me. So therefore I put proportional, right? So if needed, one can make them equal. But we agreed to search solution of time-dependent Schrodinger equation of like x capital of x times t capital of t. Do you remember it? And then we agreed that the t capital will be this this solution, like differential equation with one derivative equal to the function, so it's exponential. And this one will be solution of time-independent Schrodinger equation. Yes? A little more a little more happier. Okay, and then if you just expand this a little further, then we just write it together. So eigenfunctions of time independent and eigenvalues of time independent give us space, x capital of X, and time portions of the separated variables. Better? Okay. I do not see happiness in eyes, but at least now it is a constructive attitude. Like okay, I will solve you. Because before it was disgusting. I do not want to think about it. So phase accumulation, because everything in the power of exponential is phase, and it as time increases, phase accumulates, it grows. So probably you didn't like just the word phase accumulation. The rest it was okay. Okay, connection restored. Because I thought, okay, I was the class lost me. So now, based on how you taught me about the difference between general and surgent and particular, we can be, still will be seen here. So we can write that a solution of the time-dependent Schrödinger equation can be summation of all possible phi sub n of x e to the power minus I h bar e sub n of t, where this index n should be the same in a product, but then factors like this product are added together. So for all possible n, from 1 to infinity or whatever number of solutions is. And to be very general, we need to say that the linear combination coefficients can be also different. They do not need to come into the equal proportions. Okay. Now, the amount of solutions for differential equation is infinite, right? And we need to nail it down to specify which solution we look for. So let's assume that by some reason, by some specifics of the problem, we do know what is the initial wave function at time equals t, at t equals 0. And now the problem that we are going to solve in 15 minutes. If I feel that we are too slow, I'll just quickly jump through slides, which will be less efficient, but 5 minutes will be enough to go over all of them. So we need to find such coefficients that would make this solution to match this initial condition. Initial condition. Does it make sense? Or we need to find visual analogies of this abstract concept? Like if in high school physics you do like trajectories, everything can fall down, but depending on initial position, it will fall down quicker or sooner. So we need to fix initial position. Or if we throw something from catapult, we also need to specify the angle. Right?
What did you say has to be?
So we need to find such coefficients, and I'm not yet done with mathematical part. I'm just seeking your understanding of general concept, and then we'll go into more details. So we need to find such coefficients C, by now they are unknown, that will make this solution to match this initial condition. And now following question of Elsa. So she feels that this writing and saying is incomplete. The logic is not complete. I cannot put equal sign because here we explore this expression at any time, and here we have only one time. But maybe the only one conceptual thing, well, first one was basis functions and orthogonality. Here is the second conceptual thing that needs philosophical out-of-box thinking. The rest will be just mathematical procedures. How to match this general solution into this initial condition? Perfect. Basically, we are done. The rest will be like rolling straight forward. So if we plug t equals 0, then they should be equal to initial condition. Okay, and by plugging t equals 0, each exponential will turn into 1, and we can solve this equation as to find coefficient c with some tricks. Say goodbye to this writings. I'm going to erase it.
Like the whole class, we had Linda's office. Remember when I all gave you the pitch to be a tour guide? Had you that one, you knew how to put games and or something. Oh, yes, yeah, there was somebody that brought it to his like Maxi presentation. Yeah, those are really good. These are from Costco. Is that me?
Oh, thank you for enjoying my calligraphy. E to the power 0, which will be just 1, right? So now we have everything is well-defined mathematical problem to find C sub n. What I'm going to do? I'm going to derive something for another 5 minutes and then quickly go through pre-recorded slides. So we did agree that phi sub m star of x, phi of n of x dx should be either 1 or 0, right? So the goal is to apply this rule to this equation. Why? What is the logic? Why do we need, and how do we, if we would be the pioneers and frontiers and scouts who solve it for the first time in the global history? On the upper equation, we have function on the left, functions on the right, right? And our answers are numbers. So we need to arrive to expression which will tell C sub n equals something. So having functions on the left and right is bad, just cynically for practical purpose of solving equations. So we need to get rid of functions. So they're there, but they shouldn't be there. And we cannot cancel them because they're different. But we have a help. If we multiply one function by another and integrate, they convert into number. So turn functions into numbers. So this is a logic. So if we assume that we select a random eigenfunction of time independent Schrodinger equation phi sub m and multiply it from the left, some people hate, some people love the sound. Did I violate any mathematical rule by multiplying the equation by the same factor from left and right? No. Now, if I put an a sign of integral to the left and right, do I violate any mathematical rule? So this is a still correct equation. Do you see any similarities between our rule of orthogonality and this expression, especially on the right side?
There's the pi star and the pi negative.
Yes, and we do know that operators and functions are dangerous to swap their order, but for things like constants and summations, they're fine to swap the order. So it will be again no violation of mathematical rules if I swap the order of summations and factors and an integral. So summation n c sub n, and then integral phi sub m star phi n dx on the left, and on the right will be just integral psi m phi star m psi initial condition x0 dx. Did I violate any mathematical rule by now? I hope not. Not yet. Okay. Now, what can we say about this little box?
It's equal to either 1 or 0.
Correct. Yes, it's either 1 or 0. So it will be 1 if m equals n, and 0 if m is not equal n. Okay, 2 minutes of derivations more, and then back, and then plan B. How do we call a matrix that has 1 if indices coincide and zeros if indices do not coincide? Okay, and it is an object with 2 indices, m and n, which is a matrix, right? And if indices are the same, m equals n, it has 1. If they are not equal, it is zeros. Do you have a name for this matrix? Identity, good. And also there is another name. So if one uses letter delta and put here mn, do you saw it before? So it's delta function. There are 2 delta functions, one Dirac and another is Kronecker. No? So Kronecker delta, discrete delta. Delta means, well, I don't have background. It's just an abbreviation for this identity matrix. Okay? And then I think I need to erase, although there is not much time, but it will be too messy if I keep going. So I will just return to this expression once again. One of my strongest impression in college when there was an instructor who was wiping off the board with 2 hands, like to speed up it twice. So integral phi star m psi x0 dx equals summation over n c sub n and then just delta m n, right? So how do I interpret this situation. It is also not, I'm not taking credit. I learned it from one of my college teachers. So this sigma has angles. It's like aggressive, evil. So it's just a little snake. The delta, it can be interpreted either as a little mouse or I visualize it better as a little rabbit with like long ears. Yeah, but when these two characters meet each other, this one it's this one, and we get rid of both of them because we try to revenge, and then we erase this one as well.
So you just are left with C sub n. What did you say? So are we just left with C sub n?
We are left with C sub n. No, but very close. So when these two objects come on, they are disappearing. But as a price, everywhere where we saw index n, it needs to be replaced to index m. So we are left with C sub m. And I'm very late, but here is a rationalization. So this writing can be as C1 times delta M1 plus C2 delta M2 plus so forth. So this, among this long series, only those deltas where the index where indices are the same, only one of them will be non-zero. Others will be declined. So it will be like 0 times C1 C2 times 0, and only for C sub m it will be multiplied by 1, and all others will be zeros as well. So this parses, it picks up one element from the progression, and here we do have an answer. C sub m equals integral phi m star phi psi, not m, psi of x t equals 0 dx. So by integrating our initial condition, our past times basis function, we get expansion coefficient in front of a given to get the expansion coefficient. I know you guys need to leave, but I try to quickly share screen and jump over a couple of slides just to solidify what we did. Share screen. So it is where we arrived, right? You recognize it? And here is time dependence, example of orthogonality, how to multiply, then how to do this integration, practice orthogonality, remember that it is a delta, Kronecker delta, two characters cancel each other, picking up from the progression, weight coefficients or expansion coefficients is equal to integral of initial condition times one of the functions. So here is the solution, right? We plug this coefficient C into there. So we have third way to predict future. Meeting is done. Looking forward to see you on Wednesday. So the lecture could be delivered in 2 minutes. I don't know why you were discussing it for so long.
It could be delivered, but could it be understood?
No,